This video is going to be on lesson 2.4, which is on the product rule. So here's what the product rule says. If both f and g are differentiable, then so is f times g. So basically what the rule or the product rule is going to be is as follows. So if we have two polynomial functions, f times g, and we want to take the derivative of f times g, it's going to be equal to the first function, which would be f, times the derivative of the second function plus the derivative of the first function times the second function. So there's sort of a shorthand that I want you to, I'm always going to say when I notate this. So we've got f times g, and I want the derivative of this. I'm going to call this first function actually u, and this second function v. And then what the derivative of this will be, it's going to be u v prime. So u v prime plus v u prime. So it's the first function times the derivative of the second plus the second function times the derivative of the first. Okay? So let's apply this in some examples. So differentiate the following. So I've got two different functions that are being multiplied together. So I'll show you the two different ways. Using the product law, I'm going to call this first function u and the second function v. So the derivative would be y prime, and it's going to be u v prime plus v u prime. Okay, so y prime is the derivative of y. It's going to be u and then the derivative of the second. So u is x cubed times v prime. So v prime would be the derivative of this guy. So the derivative of 15x to the 4, 15 times 4 would be 60x to the 3. So this is u v prime plus v. So v is my second function. So v is going to be 15x to the 4 times u prime. U prime is the derivative of the first. So the derivative of this would be 3x squared. Okay, let's clean this up. Y prime is equal to, we'd have 60, add your exponents, x to the 6, plus 15 times 3 is 45, x, add your exponents to the 6. These would be like terms, so I could add the numerical coefficients in front. 60 and 45 would give you 145 x to the 6. Sorry, 105 x to the 6. And that would be the derivative. Now, one thing hopefully you noticed is we could have done this a different way. How we could have done this is I could have just combined these two terms together, right? So let's just do that as an alternate method. So y is equal to, there's a 1 here. So 1 times 15 is 15. And then x to the 3 and x to the 4 would give you x to the 7. And then from here, I could have just done the power rule to this. So y prime is equal to 15 times 7 is 105 x to the 6. Right? So if you see shortcuts, you could take the shortcuts, but this homework lesson, it doesn't want you to take any shortcuts. It wants you to use the product rule for everything. Okay, so just sort of make sure you understand that we'll get the same answer if I would have cleaned this up. So this one here, let's denote this as u and this is v, but I'm going to rewrite this as y is equal to 5x to the 7, and then let's bring that x, let's reciprocate it, so 6x to the negative 1. So again, the derivative of this is going to be u v prime plus v u prime. So y prime is equal to u is 5x to the 7. V prime is the derivative of this. So the derivative of 6x to the negative 1 would be negative 6x to the negative 2. So u v prime plus v, so v with 6x to the negative 1. So let's see, u v prime plus v, and then u prime is the derivative of the first function. So that would be 35x to the 6. Okay, y prime is equal to 5 times negative 6 is negative 30. X, add your exponents, 7 plus negative 2 is 5. Plus 35 times 6. So 5 times 6 is 30. 6 times 3 is 18. Plus 3 is 21. So 210. And then add your exponents. 1 and 6 would give you x to the 5. X to the 5 and x to the 5 are like terms, so let's add the numerical coefficients in front, and we'll get y prime is equal to negative 30 plus 210 would be 180, x to the 5. Okay, this question here. We could expand this out, right? Yesterday, if I would have given you this question, or in the last lesson, we would have expanded this out, and then we would have taken the derivative of each term. But it wants us to get the derivative by using the product law. So we're going to call this first one. My first function is u, and my second function is v. And then the derivative will be u v prime plus v u prime. So y prime is equal to, so u is first, and then v prime is the derivative of the second function. So the derivative of this would be 6x minus 1. So there's u v prime plus v. So v is my second function. So u v prime plus v, and then u prime. So u prime would be, the derivative of u would be 6x squared. Okay, let's clean this up now. So y prime is equal to, we're going to expand out these two binomials. So we'll get 12x to the 4 minus 2x cubed plus 30x minus 5 plus, let's expand this out, and we'll get 18x to the 4 minus 6x to the 3. Then let's do our like terms. So the derivative, we'll do it in descending order of x. X to the 4s will go together. That will give me 30x to the 4. And then my x cubes. And then plus 30x minus 5. What I want you to do is I want you to pause this video, and I want you to take that original function, or two functions. So here's f and g. And what I want you to do is I want you to do this an alternate method. So I want you to expand this out, and then I want you to take the derivative of each term, so what the last lesson was on, and make sure you get the exact same answer. Okay, so give yourself a couple of minutes to do that. Okay, this question here, let's rewrite this one. So f of x is equal to 7 minus x squared, and then I'll change the square root of x to be x to the 1/2. Again, The easier way to do this one would be to distribute in this x to the 1/2 and then just to do the power rule. But let's see that we get the exact, so you could do that, like pause, expand it in, take the power rule. But let's actually do this question using the product law. So u and v. So f prime of x is equal to uv prime plus vu prime. F prime of x is equal to u is 7 minus x squared times v prime. So the derivative of this would be 1/2 x to the negative 1/2. So there's uv prime plus v would be x to the 1/2 times u prime. So the derivative of this, the derivative of 7 is 0, and then the derivative of negative x squared would be minus 2x. Okay, let's clean this up. So f prime of x is equal to, I'm going to take that 1/2 x to the negative 1/2, and I'm going to distribute it here and here. So that would be 7 over 2x to the negative 1/2. And then this times this would give me negative 1 over 2x. I need to add those exponents. So I need to add 2 and negative 1/2. I'll get common denominators. So what does that give me? 3 over 2. And then I have plus, so negative 2 times 1 would actually give me negative 2. And then I've got 1/2 times, or sorry, 1/2 plus 1. So 1/2 plus 1 will give me 3 over 2. Okay, from here, let's add our like terms. So our like terms would be this x and this x can go together. So f prime of x is equal to 7 over 2x to the negative 1/2. Now I've got negative 1/2 minus 2. So negative 1/2 minus 2. So negative 1 minus 4 will give you negative 5 over 2. Okay, and then from here, I'll show you how I'd clean this up. Actually, we'll clean it up and then we'll rationalize. So f prime of x would be 7 over 2 square root of x minus 5 over 2 x to the 3 over 2. Okay, this is the answer. But what you're going to eventually need to be able to do is have this answer cleaned up. So we want to rationalize. So I want to get, actually, sorry, I want common denominators. So I've got a 2 in each term. I want a root x in each term. So I'm going to multiply this by root x and this by root x. F prime of x is equal to, so my denominator is going to be 2 root x, and then it's going to be 7 minus 5. I've got x to the 3 over 2 times x to the 1/2. So 3 over 2, we're going to add the exponents, will give me 4 over 2, which is going to be x squared. And that's how that will clean up. I want you to pause the video and take 5-7 minutes to do these 4 questions in your homework. When you do those questions, just make sure you have the work solutions opened. So I'll sort of show you the work solutions. It wants you to use the product law for each one. So it does not want you to expand this out. It wants you to use the product law. And then question number 1 actually says don't simplify your answer. So it just wants you to do your uv prime plus vu prime and then no simplifying for question number 1. Okay, so just it wants you to practice again using product law. Once we get to question number 2, you are going to simplify. But take 5-7 minutes to do question 1, no simplifying. Okay, for these 2 questions, these are really good and they'd be more standard of excellence questions. I won't solve them in this video because they are solved in the other video. You want to watch from 10 minutes to 17 minutes, 30 seconds. I'll check your homework, or sorry, your note packages tomorrow that you've done these 2. You could try them on your own, or you could watch with the video to do those questions. We'll look at class example 2. Find the slope of the tangent line to the graph of this function at this point here. So basically what this is asking is on this curve, there's a point. The point is at 1, 5. They want to know what is the slope on this curve when x is 1. So essentially what they're going to be asking is f prime of 1. So let's take the derivative of this, and then we'll find the slope at 1. Okay, if this was an exam question, I probably would want to expand this out and then just take the derivative of each term using the power rule. But because it's in this lesson, we're going to take the derivative using the product rule. So this will be u, this will be v, f prime of x is equal to u v prime plus vu prime. F prime of x is equal to u 3x squared plus 2. V prime is the derivative of the second function, 6x squared. So there's your uv prime plus v, second function. So uv prime plus v, and then u prime. Let me just do u prime. So uv prime plus v u prime, so 6x here. Okay, we're going to expand this out, and then we'll have the derivative. So when we expand this out, we are going to get 18x to the 4 plus 12x squared plus 12x to the 4 minus 6x. F prime of x is equal to, so we'll combine the x to the 4's, and that would give us 30x to the 4 plus 12x squared minus 6x. Okay, so this is the general equation for the derivative, which basically means I could plug any x value in for x and I could find the slope at that point. They want the slope though when x is 1. On this original curve, when x is 1, what's the slope of the tangent? So that would be found by evaluating f prime at 1. So take out your x's and we're going to put in 1's. 31 to the 4 plus 12, 1 squared minus 6 times 1. That's going to give us 30 plus 12, so 42 minus 6. F prime at 1 is equal to 42 minus 6, 36. It's really important that you understand what this means. So what this means is on the original curve, so on f of x, there's a point. This is the point on the original curve. The slope at that point is 36. Okay? That is what f prime at 1 means. All right, this is a really good exam style question. So what we're evaluating is f times g, so the derivative of f times g at 2. So remember that normally what it is if this was u times v at 2, it's uv prime plus vu prime, right? That's the derivative. So what we're evaluating, I'm going to use F's and G's though. So u v prime, it's going to be f of x, so that's u. V prime is the derivative of g. So u v prime plus v, and then u prime is going to be f prime at x. Okay, so again, u v prime plus v u prime. They want me to evaluate the slope at 2. So that would be f of 2 times g prime of 2 plus g of 2 times f prime at 2. I'm just substituting in 2 for x. Okay, f of 2. So on my f function, when x is 2, what's y? So f of 2 is 6. G prime at 2. On my g function, what's the derivative at 2? So g prime at 2 is 3. Plus, on my g graph, when x is 2, what's y? G of 2 is negative 5. And then times f prime at 2. On my f function, what's the derivative or the slope of the tangent when x is equal to 2? So f prime at 2 is negative 2. This will give me 18 plus 10, and this is 28. So f times g, the derivative of f times g at 2 is 28. Okay, there's a couple more of this exact style question. So let's do this one. So again, normally we've been doing u times v, and the derivative of that is uv prime plus vu prime. Well, we're going to use f's and g's for this style of question. So f times g, the derivative of the product of those two functions of x is equal to. So u is f of x times v prime would be the derivative of g plus v, sorry, that's not v. So u v prime plus v is g of x times u prime would be the derivative of f. Okay, so now the question is asking for f times g, the derivative at 4. So we're just going to sub in 4 for all my x values. F of 4 times g prime at 4 plus g at 4 times f prime at 4. On your f graph, when x is 4, the corresponding y value is 2. On your g graph, so what is this asking? On your g function, when x is 4, what is the slope of the tangent? So on the g function, when x is 4, the slope of the tangent is 6. On the g function, when x is 4, what's the y value? So g of 4 is negative 2. And on your f function, what's the slope of the tangent when x is 4? F prime at 4 is 3. So this would be 12 plus negative 6, and we will get 6 as an answer. Okay, one last style of question would be this one. Assuming f is a differentiable function, find an expression for the derivative of the following. Okay, so what we have is we have y is equal to x cubed times f of x. So my first function I'll call u, and my second function, they don't tell me, but I'm going to call this second function v. Well, I know that the derivative is uv prime plus vu prime. So the derivative of this is going to be u. V prime would be the derivative of this function, which would be f prime of x. So uv prime plus v is f of x, and then u prime is the derivative of this function. The derivative of x cubed would be 3x squared. And then from here, we've got x cubed f prime of x plus 3x squared f of x. Later on, we'll be taking this even further and we'll be factoring. So what I could take out from these two terms, I could factor out an x squared, and I would get x f prime of x plus 3 f of x. So later on, this is how far we'll be taking it, but for this lesson, we'll be going to there. Okay, your remaining homework, one should be done. You want to do 2 ACEG, 3 BF, 4 to 7. Again, make sure you have the work solutions opened. And like I said, once I got to number two, we started expanding and cleaning everything up. And then number 3, we're going to be finding slopes of tangents, taking derivatives. Okay, so you want to have your work solutions open when you do these questions.